Hi everyone. So today I'll be solving a typical word problem from the chapter of pair of linear equation in two variable. Now which deals with downstream, upstream and downstream conditions. Okay. So the question, let's read the question. Ritu can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. Find her speed of rowing in still water and the speed of the current. So let's first understand what we mean by upstream and downstream. Suppose there is a river, water is flowing at a speed of say y km per hour. The flow of water is y km per hour, that is the speed of the current. So we have taken this as the speed of the current, speed of the current. Now suppose in a pond, say, that is where the water is standstill, that is when there is no flow of water, and if a person rows a boat in a pond in a standstill water and with a speed say x km per hour, that is the speed of rowing in still water, that is the meaning which you are asked to find, speed of rowing in still water. So x km per hour we have taken as the speed of rowing in still water. Now if the person is now starts rowing in a river where the water is not standstill, and if it flows in the same, if it rows the boat in the same direction, this is the rowing in the same direction as the current of the water in the river, then we say that the person is going downstream. And obviously, as this speed of current will increase its speed of rowing, so the downstream speed will be increased. So the downstream speed will become sum of, because he was rowing in standstill with a speed of x km per hour. So these two, this is x and this is y, so these two will be added. So x plus y km per hour. So this is downstream condition when the person is rowing in the same direction of the water flow in the river, so that speed is increased as the speed of the current is helping him to row in the same direction, so the speed is added. The speed of the standstill will be added with the speed of the current, and that will give you the downstream speed. Now if the person rows the boat in the opposite direction of the speed of the opposite direction of the flow of the water in the river, then we say the person is rowing upstream. Upstream. And so the speed will be less because he has to overcome this backward drag of by the water flow, and standstill speed is your x km per hour. And if a person has to move in the opposite direction of the water flow, then obviously this speed x has to be more than the speed of the current. That should be satisfied. Then only you will be able to move in the upstream direction. So the upstream speed will be x is more than y, so it will be x minus y km per hour. So these two things you have to be very clear about. So When in the same direction, downstream speed is more, simply addition of the speed in standstill plus speed of water flow. And when the rowing is in the opposite direction of the water flow in the river, then we call the upstream, and the upstream speed is less, and it is decreased by this speed of the current from the standstill speed. So x minus y is the upstream speed. So it is always speed of the rowing minus speed of the current, the upstream speed. So now these things are clear. What do you mean by downstream and upstream, and how the speeds are calculated, downstream and upstream. So now we are in a position to solve the question. So let me erase this. So speed of rowing, we have taken x kilometer per hour, which you have to find, and the speed of the current we have taken y kilometer per hour. This is okay. Speed of current is y kilometer per hour, speed of rowing x kilometer per hour. Then downstream speed will be this and upstream speed will be this. Now for forming the equation, what you have to do, now it is distance traveled in downstream is given 20 kilometer and time taken is 2 hours. So the speed, downstream speed, and as we know the speed is distance moved by the time taken to cover the distance. That is the basic definition of speed. So for downstream speed we can write distance moved downstream is 20 kilometer and time taken to move 20 kilometers 2 hours, so 2. And according to our basic definition, downstream speed will be x plus y and it will be 10. So we got one equation. Similarly, we can find out the upstream speed also. What is the distance moved upstream? Upstream distance is 4 kilometer. So we write 4, and the time taken to move 4 kilometers 2 hours, so it is 2. And by basic definition, upstream speed will be x minus y. It is 2. So you got the second equation. So these xy are defined before writing all these things. So now we got two very simple equations which are very easy to solve. That is simply by adding 1 and 2 you can get the values of x. Because when I add 1 and 2, this y will be eliminated, plus y minus y. So twice x is equal to 10 plus 2, 12. That will give rise to x is equal to 6. So x is 6. Therefore from equation 1 I can write what will be y. Y will be 10 minus x. 10 minus x. 10 minus x is 6. So this is 4. So our answers are speed of rowing in still water x, that is, so we write answer in this way. Answer, speed of rowing in still water is equal to speed of rowing in still water I have taken to be x kilometer per hour and x is 6, so I write it is 6 kilometer per hour. And next, speed of current we have to find. Speed of current is equal to, it is y, so y is our 4 kilometer per hour. So in this way we can find out these two unknowns. Okay, so it is very important to understand the situation, and that is what will be the downstream speed and what will be the upstream speed after you define the variables. And then using this speed is distance by time, I can form the equations, and which are generally very simple ones. And in this case it is very simple. It may not be simple every time. So okay, so next I will be giving another question where the equations will not be that simple. In that case I'll show you a technique how we can solve those difficult equations. but the question will be again of the same type, upstream downstream questions. Okay. Next question again of upstream downstream problem, where it will be a little bit more complicated than the previous one. So let's read the question. A man rows a boat 35 km upstream and 55 km downstream in 12 hours. He can row 30 km upstream and 44 km downstream in 10 hours. Find the speed of the stream and that of the boat in still water. So first we define the variables. What are the variables which are asked to find? So find the speed of the stream. So let the speed of the stream is equal to x km/h. Always give unit along with the variable when you define. And the speed, what I next you have to find boat in still water, and speed of boat in still water. We take y km/h. So after defining the variables, now we'll go to the question. So first of all, when I know the speed of stream and speed of boat in still water, we can write about the expression of upstream speed and downstream speed. So first let us write, if these are the speeds, then downstream speed will be sum of these two. That is very easy. Always downstream speed is always addition of the two speeds, km/h. And upstream speed will be speed of the boat minus speed of the boat in still water minus speed of the stream. So it will be y minus x km/h. Speed of boat in still water minus speed of stream will be the upstream speed. So now we have to form the equation. So it is given in terms of time, 12 hours. So what is time? Time is equal to distance by speed. So this one will be using in forming the equation. So let us take the case 1. Okay, in case 1, what is the situation? The person goes 35 km upstream. So time taken when moving 35 km upstream will be 35 km by the speed of the upstream speed. So 35 km is the distance and speed upstream. So upstream is your y minus x. So this much time is taken in going 35 km upstream. Then he moves in the opposite direction, that is 55 km downstream. So the time taken, that time I have to add. So that time will be time taken in moving 55 km downstream distance by the downstream speed, that is x plus y. Downstream speed is your x plus y. It's according to the question I should write. So the total time is 12 hours. So in this way, form the first equation from the first case, that is going 35 km upstream, then is moving 55 km downstream, and total time taken is 12 hours. So this is the time taken, this term gives the time taken in moving 35 km upstream, so distance by upstream speed, and this is the time taken by moving 55 km downstream, so distance by downstream speed. So the first equation is formed. So next equation will come from the second case, that is he can row 30 km upstream. So time taken in moving 30 km upstream is distance 30 km by upstream speed. Then he moves 44 km downstream, so plus distance 44 km and downstream speed, and the total time is taken is 10 hours now. So these are the basic equations we got from the question. Distance by speed gives the time taken. From this it comes. So now these equations are not linear equations. So I have to convert them into linear equation by suitable substitution of variables as I have shown you in the last videos. So what will I be doing? Obviously you look at this. 1 upon, that is, this is 35 into 1 upon y minus x, 30 into y by 1 upon y minus x. So I will be taking in this way 1 upon y minus x, that is reciprocal of the denominator of the first term I take to be variable a, and reciprocal of the denominator of the second term I take to be the another variable b. So these equations will now become this one will become 35a plus 55b is 12, and this one will become 30a plus 44b is equal to 10. So now these are linear equations in two variables a and b. So now we can directly solve either with the method of elimination or method of substitution. But as you see, method of cross multiplication, by any method, by method of substitution also. But as you see, the coefficients are quite big. Unlike the previous question where the equations are very simple, x plus y something and x minus y something. But here it is not the case because the coefficients are quite big. So what I can do to make my simplification or solution process simpler one, I can do one thing. If I observe, I can subtract one equation from the other to generate a second equation. That is, say if I subtract this from this, so 35 minus 35a, and this is your 11b is equal to 2. So I have generated an equation by simply subtracting one from the other. Now what can I do? I can use this equation. Now I will be able to substitute this equation in any other equation. And again you observe 5a is a factor of 35. 5 is a factor of 35 and 30. So I can choose any equation. Let me use this is equation 1, so this is equation 2, and this was 3. So what can I do? 3 can be written in this way. 11b is equal to 2 minus 5a. Let me write 3 in this way. So what I'll be doing now? Now I'll take this equation 2. This is your equation 2. So equation 2 can be written in this way. This equation 2 is your 30a plus 44b is equal to 10. So what will I do? You see, I'll write it in this way. 30a plus 4 into 11b is equal to 10. So 44b I have written as 4 into 11b because I know 11b is equal to 2 minus 5b. This I can directly substitute. So let me write it here. So 30a, that was the equation 2. 30a plus 4 into 11b is equal to 10. So 44 I have split it in this way, or 30a plus 4 into, what is 11b? 2 minus 5a. 2 minus 5a is equal to 10. Here I have used 3, using equation 3. This one I have used. In place of 11b I used 2 minus 5a. Now it will be very easy to solve. Or 30a plus 4 to the 8 minus 4 5 to 20, 10, or so 10a is equal to, it will go to that side, it is 2, or a is equal to 2 by 10, so it is 1 by 5. So I got the value of A. So when I know the value of A is 1 by 5, from equation 3 I get the value of B also. So now 11B, this is your 11B is equal to 2 minus 5A. 5A, in place of A I write 1 by 5. This value of A I have written. 2 minus 5A, 2 minus 5. It is getting cancelled. So 11B is equal to 2 minus 1 is 1. Therefore, B is equal to 1 by 11. So these are the values I have got. B is 1 by 11 and your A is 1 by 5. These are the two values. Now these two values I will be putting here now. So 1 upon y minus x is your A. What is A? A is 1 by 5. 1 by 5. So doing cross multiplication I am getting y minus x is equal to 5. So equation 4. Then 1 upon x plus y is B. What is B? Is your 1 by 11. 1 by 11. So by cross multiplying I will be getting x plus y is 11. So that we write this. So x plus y, that is, or y plus x is 11. So in this way I have got two very simple equations. Then by simply adding I will be getting the value of y. Twice y, x will be eliminated, is your 16. Therefore y is equal to 8. If y is 8, what will be x? From this equation I can get x is equal to 11 minus y from this. So therefore x is equal to 11 minus y. 11 minus y is 8. So 8. So it is 3. So I got the answers. So how will I write the answers? Answers will be, what was our x was our speed of the stream. So speed of stream is 3 kilo, x is 3, so 3 kilometer per hour. And next, what was y? Y was speed of boat in still water. So speed of boat in still water is your, I have taken y, so value of y is 8 kilometer per hour. So this is the answer. So in this question, basically you have to form the equations. Then the solving method I have shown you, that is how we can avoid the big calculations. If I observe, that is, I have generated a third equation, that is your 5a is yes, 11b is equal to 2 minus 5a. This one I have generated. So in this way my calculation become very simple. Okay, so this is the technique I have shown you today. Okay.